solve this system of equations. In order to do that, all we have to do is set up the corresponding augmentation matrix for this system and then row reduce. So here is the corresponding augmentation matrix. And in our row reduction, what we're going to want to do is we're going to put this matrix into reduced row echelon form, since we're trying to find exactly what the solutions to the system are, and not just how many solutions there are. So I went ahead and did this work for us to save some time, and there we are. Now, here we have our reduced row echelon form of our matrix. We can read off exactly what the free variables and the basic variables are in the system. Let's go ahead and write those out. So our free variables, there's only one, so I'll just write variable. This guy is just x3. It's corresponding to this third column here that has no pivot positions in it. And our basic variables are everyone else. Basic variables. x1, x2, and x4. Okay, now in order to write out all the solutions, all I have to do is set our free variables equal to parameters and write the rest of the solutions in terms of those parameters. So let's start this out, x1, x2, x3, and x4. Our free variable is x3, so we set that equal to a parameter. And now we can go ahead and look at x4. This guy is just equal to 1. Over here we have x2 is equal to -2 minus x3. So we can set this to -2 minus a. Since a is x3. x1 is going to give us 2 minus x3 is x1. So we get 2 minus a. And let's just go ahead and write down what a is. It's a real number. So these give us all of the solutions to the system of equations that we started with. Now there are a couple of additional questions in this question, or I guess parts. To start off, let's get a new piece of paper here. There we go. I just wrote down the solutions again, so we can have it handy. Now the first question, first new part, asks us to find any solutions where x1 is equal to 1. In order to do this, all we have to do is look at our equation here for what all of the values of x1 can be, and then figure out what the corresponding a value is, and then we can plug that into all of these guys. So if we want x1 to equal 1, then we want 1 to equal 2 minus a. This, of course, gives us that a is equal to 1, just by doing a little algebra there. Once we have a equaling 1, we get that the solution set x1 equals 1, then x2 has to equal -2 minus a, which equals -3, and then x3 would have to be 1, and x4 would also have to be 1. So we get this is a solution where x1 is equal to 1, and it's the only one. The next part that we have to answer is awfully similar to the first one. It says, find all the solutions where x4 is equal to 2. Of course, we have this little bit here, if they exist. And we know that they don't exist because in our solution set we explicitly wrote out x4 is always equal to 1. So we can say none exist. None exist. x4 equals 1. Maybe we should say since x4 equals 1. Since x4 equals 1. I think that's pretty good. If you have any questions about what I did, you can go ahead and ask me in class or in the comments below. Thank you very much.